Alright guys, so we learned the law of sines and how we could use it to solve triangles that were non-right angled triangles. So let's see how we can use this to solve an application problem for a real world example. So let's say we have an airplane and the pilot's wanting to fly from one point to another. So if we drew this out, it might look like the pilot flying from point A to point B. So just flying straight from one destination A to destination B. Okay, but before he can really get out of point A, he is radioed and told that there's a storm directly between points A and B, and so that he's going to have to divert course. So instead of flying directly from A to B, he's going to divert course and fly out of his way. He's going to divert course 15 degrees away from his original course. And then after he gets out a little ways, he's going to stop and go back to his original destination. So we'll call that point C where he makes the turn. And this turn would be the equivalent of 140 degrees. And between these 2 points, he flew a total of 100 miles. All right, so what if I wanted to find out how far our pilot flew total? So how far did the plane fly? All right, so we can solve this using the law of sines. Now, for the law of sines to work, we need to have a matching pair. So currently, I have 15 degrees. I do not know side A. It's an unknown currently. I have 140 degrees. I do not know side C. That is an unknown. And I have 100 miles, but I do not know side or angle B. Now, we can find angle B because we know these two angles, and we know that all three angles of a triangle are going to add up to 180. So I can come over here and I could say, well, 180 minus 15 degrees minus 140 degrees is going to give me a total of 25 degrees. So angle B is going to equal 25 degrees. So now that we know that, we do have a matching set of information. We have 25 degrees and that side that goes with it, 100 miles. So we can use these to solve for our two missing sides. So if we want to know how far our plane actually flew, we're going to need to solve for side A so that we can add it to the 100 miles of our first part of our flight. So I'm going to set this up for the law of sines. So this would be the equivalent of 100 over the sine of 25, and that's going to equal A over the sine of 15. All right, so now to solve for side A, I'm going to multiply both sides by the sine of 15. All right, over here, these are going to cancel out, leaving with just A. And over here, I'm going to have 100 divided by the sine of 25 times the sine of 15, which, if I work out, is going to give me 61.2. 61.2 miles. All right, so side A is going to equal 61.2 miles. So, if I wanted to know how far our plane actually flew, I could take my 100 miles that we originally flew from points A to C and add that to the 61.2 miles that we flew from C to B, and I would get that our plane had to go 161.2 miles to reach its destination. So, what if we wanted to find out how far our plane would have originally flown had we not had to divert around the storm? So we want to find the original distance we would have flown from A to B. So we can solve this problem. How far was original distance? All right, we can solve this problem much in the same way. So we can take our information that we had earlier. So we have the 100 miles over the sine of 25. All right, and we're going to take that and set that equal to c, which is what we're trying to figure out, over the sine of 140. All right, so again, to solve, I need to multiply this side by the sine of 140. I need to multiply this side by the sine of 140. Over here, these are going to cancel out, and I'm just left with c on my right side. On the left side, I would take 100, divide it by the sine of 25, and multiply it times the sine of 140. And if I do this, enter it into the calculator. So we have the 100 divided by the sine of 25 times the sine of 140. We get that the original flight would have been 152.1 miles. So you can see how we could use the law of sines to solve this problem using real-world data, and how we can use this to apply to many other problems. So it always helps if you draw the picture, much like we did here. So this is very similar to one of the problems you had for homework, so double check over it, make sure you did it right, or maybe this will help you figure out how to work it. And we will post more later. Thanks for watching, guys.